going to see where did those equations come from. So, I said this is a summing amplifier, this is an inverting amplifier. Where did those come from? So now we're going to see, I think that, let me see if we're going to do that on this one. This is problem 3. Okay, so no, we're actually not. On this one, we're going to compare this to the amplifiers that we know something about and use that information so that we don't have to solve the circuit. And then we'll do some where we do solve it. Okay, so we take a look at this one, and we want to look at the important parts here. And the important parts, so just, let me just grab this. Okay, and now let's compare this to our circuits here. And we don't really care that we have a resistor on the load, because our V out is really right here. That's our V out right there. So the resistor on the load doesn't really affect anything here. And so when we look at this, we can see that this is a non-inverting amplifier, and the reason it's a non-inverting amplifier is we have, if this is V, okay, so if this is V out right here, so this is V out right here, then we have a resistor right here, and that's this resistor, and we have a resistor right here, and that's this resistor right there, and that is all here at the negative. Now we also have this resistor that's going into the positive terminal, but that's not really part of the op amp, because it's not really, it's not connected to any of the parts that are the feedback. So that part is not, it does not affect anything. So this is a non-inverting amplifier, and I'm actually going to grab this picture. Non-inverting. It looks more like this one, I think. No, just not going to go. Okay. I use one note and I curse one note. Okay. So if we look at our non-inverting op amp here, then we see that the gain is R1 plus R2 over R2. And so that our V out equals our gain times our V source. So here it's saying assign a resistance value so that the circuit would deliver 75 milliwatts of power to RL. So the first thing that we have to figure out is what that's going to tell us what we need our V out to be. So we know that power equals V squared over R. And so I'm looking for the power for delivered to RL. So RL equals RL times P equals V squared, or V equals the square root of P times RL. And the power was 75 milliwatts, and our load resistor was 3 kiloohms. And so a milli times a kilo cancels each other out. So this is the square root of 225, which is 15 volts. So we need V out to be 15 volts. And now if we compare this op amp with this op amp right here, here we can see, okay, well, the diagram, it matches up perfectly. And so this is equivalent to R2. This is equivalent to R1. So we need R1 plus R2 over R2 times our input voltage, our source voltage, which is 3. We need that to equal 15. So we need R1 plus R2 over R2 to equal 5. And we know R2 is 4. So R1 plus 4 over 4 equals 5. R1 plus 4 equals 20, or R1 equals 16. And so if I didn't miss any, I did, these is kiloohms, right? And so this would be kiloohms. So what I did was I recognized the type of op amp that it was, and then I said, well, based on this kind of op amp, I know that in order to get the V out that I want, I need to figure out what my R1 and R2 need to be. And so I just plugged in and solved for that. But that was because I was able to recognize what kind of op amp it was. A lot of times you're not. A lot of times you'll have to figure out, and that'll be what your job is.
So non-inverting because the positive is on top?
No, that's not why it's not inverting. It's not inverting because it looks like this. So you see I've got this feedback into the negative. You see how it matches up one for one with this right here. So this is R2, this is R1, this is RS, which is, yep.
Did you get the V0, V output equals from V source? Is that fun?
This is what op amps do. Yep. So op amps, the out equals your gain, your G, times your source.
And G could also just be placed in the V.
Yes.
I mean, G could also just be A.
If you're using the first page that has the A's on it. It's not the A that's the internal open loop gain, because that A is like a million.
Yeah. I remember him talking about it, and he said it meant V closely. I mean, A closely.
Yes. Yep. Okay, other questions? All right, so I'm going to stop this one.